Imagine you're over for coffee with an old high school buddy. You both share a love for coding, and today you decide to dive deep into the world of Python, specifically tackling the Fibonacci sequence. Your friendly guide to this journey is me, and you've been hearing tales on optimization through memoization and generator expressions. Let's set the scene. Hey, friend, remember our old Python teacher and that peculiar series called Fibonacci? No, it's not from that Italian baker but the magical sequence of Fibonacci numbers. Intrigued? I grin, tasting the sweet concoction of nostalgia and coding adventure. Let's start from the very beginning with the traditional way of writing a Fibonacci sequence. In Python, we would just declare a simple function that calls itself to calculate the next number in the sequence. As I sip my coffee, I walk through the code with enthusiasm. Each Fibonacci number is the sum of the two preceding ones, starting from 0 and 1. Here's how you could write a basic recursive function in Python: definite Fibonacci, if n happy smiley 1, return n else, return plus Fibonacci. Your friend listens attentively as though the code itself is speaking in a language only they comprehend. I continue, the excitement in my voice unwavering. Now, recursion is elegant, isn't it? But like that one time when we raised rabbits on the weekend and had a munchkin run after our rabbit. Recursion with the Fibonacci sequence can get overly complex as you move to larger n values, resulting in an explosion of calls, not a good sight at all. The imagery of rabbits fades into my narrative of bottlenecks, and so, I learned about iterative approaches. Python is great for loops and lists, right? Let's use that to calculate the Fibonacci sequence the simple way without the excessive calls. I sketch the code on napkins. Python definite Fibonacci underscore iterative fib underscore sequence is equal to for I in range fib underscore sequence dot append return fib underscore sequence. The steam from the cup merging into the swirls of logic. Our algorithm now only needs to keep track of the last two numbers, hence it runs in constant time after we compute the first couple of elements. That's O overall, but so much prettier and efficient. I pause as you ponder the simplicity of this approach. Now, let's talk memoization because it's like taking homework and turning it into cheat sheets. By remembering the results of expensive function calls and reusing them, we avoid unnecessary repetition. Waving the napkin with the cheat sheet code in my hand, I hallucinates Python definite Fibonacci underscore memoized, if n in memo, return memo if n happy smiley 1, return n if n not in memo. Memo is equal to Fibonacci underscore memoized plus Fibonacci underscore memoized return memo. The swirl in the cup returns, mirroring another whirlpool of understanding awe. And when it comes to tailoring our algorithm to save memory, I tell you, Python list slicing is not just for cutting cake. We can replace list with a tuple, thus storing only the last few terms needed for computation and trim down memory usage. Before a hearty chuckle bubbles up, I throw another curveball. What about the Fibonacci sequence as lazy functions with generator expressions? We don't really need the entire sequence at once, right? I draw from the bottom of my cup. A generator expression can generate the sequence term by term when needed, perfect for handling large n without storing the entire sequence. Like a perfectly brewed espresso. I let the words cascade over us, filling the silence between us, and if you want a Fibonacci generator as an infinite loop, Python's got your back with that one. I finish my coffee. The journey through Fibonacci functions comes to an end. Visit neeraj.qzz.io and subscribe to TechLab whenever you feel peckish for more programming talks. Got an algorithm to decode or a concept to unravel? You nod, Your mind buzzing with Fibonacci functions weaving through recursion, iteration, memoization, and the magic of lazy evaluation. And with that, the tutorial concludes, the essence of learning interwoven within the fabric of our time together. Let's head out and see what Python marvels await in the digital cityscape outside. Visit neeraj.qzz.io and subscribe to TechLab. That's where the pulse of tech beats strongest for us programming aficionados.